I've come into the studio to investigate the next weather phenomenon because here in the UK we're fortunate to rarely encounter hurricanes.
Cyclones, typhoons and hurricanes are all names for severe tropical storms, some of the most destructive weather systems on the planet. Storm force winds, torrential rain, massive pressure falls and storm surges are all produced simultaneously by this most deadly weather.
Around the Indian Ocean and Southeast Pacific, these massive storms are known as cyclones. Cyclones tend to affect countries like Madagascar, India and parts of Australia. In the Northwest Pacific, tropical storms are known as typhoons. Typhoons hit the headlines when they affect countries like Japan and parts of Southeast Asia. But the tropical storms we hear most about occur closer to home, hurricanes. Hurricanes hit the headlines when they wreak their damage across the Caribbean and parts of southeastern USA.
You might remember the last really big one, Hurricane Katrina, which struck New Orleans in August 2005. This devastating hurricane was one of the most expensive natural disasters in history. But whilst hurricanes wreak their damage around the Caribbean and the USA, most of them begin life thousands of miles away, out in the Atlantic, close to northwest Africa.
Hurricanes draw their energy from warm seas and can only develop where the sea temperature is 26 degrees Celsius. And they can only develop into major storms when the sea temperature is 28 degrees Celsius, which is like a warm bath, so we're unlikely to see them off the UK coast anytime soon. Like a grain of sand in an oyster creating a pearl, hurricanes require two elements to form around, either developing wave patterns or thunderstorms, neither of which are found under areas of high pressure, where descending air tends to keep the atmosphere stable and the weather generally fine. Other limitations, such as wind patterns in the upper atmosphere and the force of the rotation of the Earth, mean that hurricanes can only develop around a narrow band between 8 and 20 degrees north of the equator. That may seem like a really small area, but it's where the easterly trade winds converge and there's a plentiful supply of moisture. So it's a prime location for developing thunderstorms and the birthplace of the majority of hurricanes.
Everything is in place. Converging trade winds meet. The warm air, heavily laden with water vapour, is forced to rise. In the cooling air, water vapour condenses into droplets. This change of state from water vapour to liquid releases latent heat, which further warms the atmosphere and allows it to become more and more buoyant. The air rises even more rapidly and produces more and more violent thunderclouds.
But that's only the beginning. Trade winds drawn in at the Earth's surface arrive on a curved path due to the Earth's rotation. Here we see the first recognisable pattern of a spinning tropical storm. As the storm grows larger, more moist warm air is drawn in at the surface. More water vapour condenses into cloud droplets and more latent heat is released. This is how energy is driven into the storm and the speed of rotation increases. This system is now a tropical storm, and when the surface wind reaches sustained speeds of over 74 miles an hour, the storm is officially a Category 1 hurricane.
We've all seen pictures of hurricanes hitting land, but what's happening inside the storm?
Rising currents of warm, moist air form thunderclouds. As the air cools, it becomes more dense and falls again, and we get this alternating pattern of storm clouds with clear slots in between. This gives us the appearance of spiralling rain bands, which we see on satellite pictures looking down on hurricanes from above.
Hurricanes are measured on a scale from 1 to 5 depending on the wind strength. As a hurricane grows in intensity, it develops a very distinctive structure with what looks like a hole in the middle of a swirling mass of clouds. This clear zone in the centre of the storm is called the eye, and around it is the eye wall. The eye wall is the most destructive part of the hurricane, containing the most severe thunderstorms and the very strongest winds. In a Category 5 hurricane, winds in the eye wall can exceed 155 miles an hour. Yet in the eye itself, the wind drops right away to give a short-lived, eerie calm.
As well as causing massive damage simply because of their destructive strength, hurricane-force winds can have an even more devastating side effect. Have you ever blown hard across the surface of a hot drink and spilt a little bit over the side?
In 2005, Hurricane Katrina blew a wall of seawater, known as a storm surge, ahead of it, which was 8 metres high. It swept over New Orleans sea defences, engulfing most of the city. We are getting better and better at forecasting the strength and direction of hurricanes, giving people living in their path precious time to protect themselves and their property. And we are even able to predict roughly how many storms there will be in each Atlantic hurricane season, information that's very valuable to the insurance industry.
But we still have lots to learn about tropical storms, especially what the impact of climate change will be on the strength and number of these storms and where they're likely to wreak their destruction. If you want to learn more about hurricanes, there's loads more information on the Met Office website.